So they think that they looked at this a lot and they think that it's going to be easy for you, but they're looking at a finished thing. So in your problem that I just gave you, I have the solution to, and I have the graphical method. That is important for you for the WPR because you're not going to get exempt. So any question that has you going through the solution, you're probably going to have to use the graphical method. That's the only thing that's manual that you know how to do. So that one, I would, if you didn't practice that originally, I'm going to give you some reps with that in class, and you're going to have to know it. But if you read this problem, the story of the problem is, there's this guy, he just wants to have steak and potatoes. He's going to have servings of steak and potatoes, but he wants to meet the national recommendations. So which are the constraints? He's got to get 50 grams of carbs, 40 grams of protein, and 60 grams of fat. And I actually have all the work, the algebraic formulation on there, and I even have the solution on there. So you can see, we'll build up the actual range. So I built some tools in here. So you have the constraints x bigger equals 0, y bigger equals 0. This is 5x plus 15y is bigger equal 50. That's the blue graph. Then I have this A and a D and an M here. That's actually your protein graph. And I'm going to slide my A. As soon as you do something like this, it'll ask you, do you want to add a slider? I'll show you how that works. But my A in this case is 20, so I'm going to move this up to 20. And then the D is 5, so I'm going to move this down to 5. But now I can toggle these, and why that's important is I can look at how things change if the A and the D weren't quite right. That's what it does for me. And so the M is, in this case, I can't read my own writing, 40? Yeah, so it's already set. So, and then a little further down, I have the 15x, and the B was 60 in this case, I think. Fat calories?
Yes.
Right. So that's the third one. And then I have this objective function here. It dawned on me that actually there's a lot of confusion when people work on Desmos too much. But somebody asked me, if I give you this line, can you give me the objective function? The answer is absolutely not. You need more information. I need to know, I've set C to be something here, so now I can get you the objective function. But I can slide the C, and this actually makes a plane in 3 dimensions if I graph it, but I can actually give a value for C and look at a constant set of solutions. And if I know that the best answer is going to happen at the corner points, I can slide it around and see, like, that feasible region now is this trapezoidal weird looking thing right here. It's like this, outlined like that. And now I can slide around my C to see like where it happens. And you can see that C equals 12 looks like it's almost minimal. What did I get as an answer? 10? Yeah, that looks right. You see that when I slid down C to be 10, that's this bottom corner point here. That's the corner point that gives me the minimal solution for cost. If I slide it anywhere else at another corner point, tell me when to stop. I want to see if you're getting it.
That's not too far.
Okay, there you go. That's the other corner point, 19. And it looks like 19's matching where equation 1 and 3 meet. So it's where these two meet. That's the corner point. And I get cost is 19s. So I can slide this thing around to the corner points and see where it's. There's another corner point. There's one up here, right? So I can slide that up. So I can slide C up. This is the stuff that I'm worried that I haven't done with you guys that other classes are doing. I can slide it up here, and that's 60, and that's the y-intercept. That's the maximum value. Maximum and minimum values are both caught by looking at the corner points. Do you get how this works? Because I'm going to actually send this to you guys and then have you play around with a few questions that I have there. So how do you get one of these to be built by yourself? Let's say I have an equation and I put some See, it popped out as add slider. I just made something up. So if you go click the add slider, it'll allow you to slide around. But if you can choose your minimum and maximum values too. So you can put in like 10 and 20. And then you can have it step up by like 0.1 if you want, so that it doesn't, like it moves around out of continuous stuff. So that's how you build one of these things. It's pretty simple. Desmos is a good tool. All right, so I'm going to send this to you. And the first question I have here is, what if that total grams of protein required was, and this is true, these come from studies, that's found in healthy people. That's what we call an observational study, because they observed healthy people and they looked at how much protein they consumed. The only way you can actually get that number, by the way, is if you lock people up. Because if they're out in the public, they might eat stuff like this. And first of all, I don't have any idea how much protein you're getting from this. Second, if I told you not to eat it, most people will go and eat it if you put it in front of them. So, but that's beside the point. But let's suppose that that was not actually, the requirement was not actually 40, but it ranged from 30 to 60. The first question I have for you is, tell me what happens to that feasible region, and then go and put your answer on the board of what you think the feasible region has. Do your corner points change? Do they disappear? Does that feasible region get smaller or bigger? So slide around and see what happens when you're doing this. And so let me send this to you. Sent. And if you didn't get how to use this, it's actually a good tool to use for your homework too. You can use it. Actually move your desks around so you work in groups of 4. So you can talk to each other. You guys should get to know each other. Yes, I do want these. Huh? Yeah, doing it. As what? Yeah.
One more year.
Push your desks together. You're allowed to rearrange the room. This is the light. Sometimes I go down to the Buckner room and people have like 45-pound weights stacked up in a pile that they're dragging. This is the lightest thing you're going to have to carry today. Did you guys get it?
Yeah. Oh. Yeah. Actually, it's that private Seidman. I won't answer that.
All right, so I just sent it to you. Anybody not get a copy of this? I might have printed out enough once.
There was just one quote on